Article 314 of the National Electrical Code, specifically Section 314.16a, addresses outlet boxes, junction boxes, and conduit bodies used in electrical installations. Table 314.16 provides minimum dimensions for outlet boxes and conduit bodies. Note 8 to Table 314.16 is crucial when dealing with boxes having dimensions different from those explicitly listed in the table. This note dictates that for such boxes, the volume of the box shall be increased or decreased to provide an equal or greater volume compared to the standard boxes listed. To determine the fill calculation for a larger box, like a 6" by 6" by 4" box, firstly you must calculate the total cubic inch volume of the box. The volume is calculated by multiplying the depth, width, and height of the box, all measured in inches. In this case, 6 inches multiplied by 6 inches multiplied by 4 inches equals 144 cubic inches. Secondly, refer to Table 314.16 to find a standard box size that has a volume close to the calculated volume. This will give you a reference point. Thirdly, compare the calculated volume of your box to the standard box's volume. The NEC requires that the volume be equal or greater, ensuring that there is enough space for conductors, devices, and any necessary fittings. To clarify this with an example, let's use a standard 4" square box that is 2 and 1/8 inches deep. According to Table 314.16, this box has a volume of 30.3 cubic inches. Now consider our 6" by 6" by 4" box, which we calculated to have a volume of 144 cubic inches. Since 144 cubic inches is significantly greater than 30.3 cubic inches, the 6" by 6" by 4" box meets the NEC requirements for volume. To apply this knowledge effectively, firstly you need to accurately measure the internal dimensions of the box. Ensure you are using inches for all measurements to avoid errors in your volume calculation. Secondly, calculate the box volume precisely using the formula volume equals length times width times height. This calculated volume is what you will use for your fill calculations. Thirdly, consult NEC Table 314.16 in Note 8. Understand the listed box sizes and the directive to adjust volume calculations for non-standard boxes to meet or exceed the required volume. Next, apply the fill calculations outlined in NEC 314.16b and 314.16c. These sections specify how to account for conductors, device yokes or straps, equipment grounding conductors, and cable clamps when determining the allowable fill. Remember that each conductor, device, and fitting contributes to the overall fill of the box. Finally, ensure that the box volume, after accounting for all conductors, devices, and fittings, does not exceed the maximum fill volume allowed by the NEC. This step is crucial to ensure code compliance and safe electrical installations. Another essential aspect is understanding conductor fill requirements. According to NEC 314.16b, each conductor that originates outside the box and terminates or is spliced within the box must be counted. This includes equipment grounding conductors if they are present. Conductors that run completely through the box without a termination or splice are counted as one conductor. The number of conductors is critical in determining the required box size. Device fill is another critical factor. NEC 314.16c specifies how to account for devices such as switches, receptacles, and lighting outlets. Each device yoke or strap, whether it supports one or more devices, is counted as 2 conductors. This requirement ensures that the volume occupied by these devices is appropriately considered in the fill calculation. Equipment grounding conductors also impact the fill calculation. NEC 314.16b5 outlines how to account for equipment grounding conductors. The general rule is that all equipment grounding conductors entering the box are counted as a single conductor based on the largest equipment grounding conductor entering the box. This simplification streamlines the fill calculation while still ensuring adequate space for grounding conductors. Cable clamps, as specified in NEC 314.16b2, also contribute to the box fill. If the box contains cable clamps, each cable clamp counts as one conductor. This requirement is important to consider when using non-metallic sheath cable or other wiring methods that require cable clamps for secure termination. The NEC also provides guidelines for conduit bodies, which are addressed in Article 314. Conduit bodies, such as LB fittings and pull boxes, have specific fill requirements. The fill calculation for conduit bodies typically involves considering the size and number of conductors passing through the conduit body. The NEC provides specific tables and guidelines for determining the allowable fill for different types of conduit bodies. Understanding these requirements is essential for compliant installations. When dealing with different wiring methods such as non-metallic sheath cable, armored cable, or conduit, the fill requirements can vary. Each wiring method has its own set of rules regarding conductor sizing, cable clamps, and support requirements. It is important to consult the appropriate sections of the NEC to ensure compliance with the specific wiring method being used. In practical application, consider a scenario where you are installing a receptacle in a 4-inch square box with a depth of 2 and 1/8 inches. The box contains 4 number 12 AWG conductors, 1 receptacle, and 2 equipment grounding conductors. To calculate the box fill, firstly determine the conductor fill. 4 number 12 AWG conductors count as 4 conductors. Secondly, account for the device fill. The receptacle counts as 2 conductors. Thirdly, consider the equipment grounding conductors. Since all equipment grounding conductors are treated as a single conductor based on the largest conductor size, the 2 number 12 AWG equipment grounding conductors count as 1 conductor. Finally, calculate the total fill. 4 conductors plus 2 conductors for the receptacle plus 1 conductor for the equipment grounding conductors equals 7 conductors. Referring to NEC Table 314.16, a 4-inch square box with a depth of 2 and 1/8 inches can accommodate 9 number 12 AWG conductors. Therefore, the installation complies with the NEC requirements. Another scenario involves using a 6-inch by 6-inch by 4-inch junction box to splice multiple conductors. Assume the box contains 10 number 10 AWG conductors, 6 number 12 AWG conductors, and 3 cable clamps. To calculate the box fill, firstly determine the conductor fill for the number 10 AWG conductors. 10 number 10 AWG conductors count as 10 conductors. Secondly, determine the conductor fill for the number 12 AWG conductors. 6 number 12 AWG conductors count as 6 conductors. Thirdly, account for the cable clamps. 3 cable clamps count as 3 conductors. Finally, calculate the total fill. 10 conductors plus 6 conductors plus 3 conductors equals 19 conductors. Using NEC Table 314.16 and Note 8, determine if the 6-inch by 6-inch by 4-inch box has sufficient volume for 19 conductors. The volume of the box is 144 cubic inches. Consulting the NEC, find the cubic inch volume required for each number 10 AWG and number 12 AWG conductor. For number 10 AWG, it's 2.5 cubic inches per conductor, and for number 12 AWG, it's 2.25 cubic inches per conductor. Multiply the number of conductors by their respective cubic inch requirements and sum them up. 10 conductors multiplied by 2.5 cubic inches plus 6 conductors multiplied by 2.25 cubic inches plus 3 cable clamps multiplied by 2.25 cubic inches. 25 plus 13.5 plus 6.75 equals 45.25 cubic inches. Since the box has a volume of 144 cubic inches, it is sufficient. In summary, accurately measuring the box dimensions, correctly applying the conductor, device, and cable clamp fill calculations, and consulting the appropriate NEC tables are crucial steps in ensuring compliance with box fill requirements. Always prioritize safety and adhere to the NEC guidelines to prevent overloading boxes and ensure safe electrical installations.